Hi, so in this video we're going to talk about Lewis structures, and for that we need to have a few conceptual backgrounds and we're going to discuss it. For Lewis structures for atoms and molecules. So firstly we need to be aware of the concepts of valence electrons. Valence electrons are the electrons that are present in the valence shell of any atom. And what is valence shell? Valence shell is the outermost shell, right? So how can we find the valence electrons? We can just find it from their relative position in the periodic table. As you guys can see, if you guys just name every column 1, 2, 3, 4, 5, 6, 7, 8 while ignoring the transition elements which come at the center of the periodic table, you will see that these particular elements that lie in this column will have one valence electron. The elements lying in this column will have two valence electrons. Similarly, for 3, 4, 5, 6, 7, 8, they have the relative valence electrons according to this particular numbering, except this particular helium that won't have 8 valence electron, it will have 2 valence electron. It is an exception. Alright, for example, if I want to draw the Lewis or dot structure for chlorine, so I know that chlorine has 7 valence electron because it is in group 7a, fluorine, chlorine, bromine, iodine. So what will I do? I'll just draw the lone pair of electrons in the form of a pair just around the chlorine. So this is the Lewis structure for chlorine. Similarly, if I talk about hydrogen, it has only one electron, so I just put one electron just adjacent to the hydrogen. But for H2, this particular hydrogen has one electron, other hydrogen has one electron. They will meet together and they will just kind of meet together to complete each other duets, right? So for hydrogen it is important to complete each other's duets, or in other words, this particular bond or this particular covalent sharing can be represented by this line. So this line means this particular 2 electrons. Now if I talk about this hydrogen molecule, this hydrogen atom has 2 electrons and this hydrogen atom has 2 electrons, because now they are sharing, right? So these 2 electrons belongs to both of them, right? So now how can we write the Lewis structure for molecules? There are a few steps and it is very simple. Okay, the first step is you have to count all the valence electrons, right? Okay, let's just take an example. Our example is this H3O positive, right? Okay, so first step was count all the valence electrons. So I have hydrogen, I have oxygen. So the valence electron of hydrogen is like there is one electron of hydrogen. Since we have 3 hydrogens, so 3 multiply 1 by 3. And for oxygen we know this 6 valence electrons because it is in this particular. So 6 1 the 6. So the total would be 6 7 8 9 valence electron. But we know there is a positive charge. It means the deficiency of 1 electron. So we'll just minus 1. It means we have total available 8 valence electrons. So the first step is done. We have counted all the valence electrons. Step 2. Determine the central atom. The central atom is the lonely said element, right? And in this the lonely element is oxygen because there are 3 hydrogen. So in most of the scenarios the element that is all by himself will be the central atom. So I'll just draw the central atom and draw all the other atoms just around it. And the next thing is you have to draw the single bonds connecting central atoms to the adjacent atoms. So this is a single bond, alright, around oxygen central atom, hydrogen, hydrogen, hydrogen. Now count the remaining electrons and put them as lone pairs. So firstly let's see how many electrons I have already used. I have used 1, 2, 3, 4, 5, 6 electrons because this single line means 2 electrons, just as I've already told you. So I have already used 6 electrons, right? So I just put 8 available, 6 I have used by drawing the single lines. Now I have 2 electrons. Now the thing says that put the remaining electrons as lone pairs. So I just put the remaining electrons as lone pair, right? That's it. Okay, the next step. Okay, turn lone pair to double or triple. Do that only to satisfy the octet rule. But for hydrogen you have to satisfy the duet rule. Duet rule is that it should have 2 electrons in its valence shell, and the octet is that it should have 8 electrons. Okay, let's see and let's find out if the duet and octet rule is satisfied or not. So for hydrogen, if you see, this hydrogen has 2 electrons, right? Because this shared mean this belongs to both of them. So hydrogen is happy. This hydrogen, 2 electrons, happy. This hydrogen, 2 electrons, happy. Duet is satisfied. But for this oxygen, let's find out if this oxygen is happy or not. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. Alright. 8 electrons mean octet rule is satisfied. So oxygen is happy as well. But there is one additional step that we do to make sure our Lewis structures are stable. Make sure the formal charge is minimum as possible, minimum or close to 0. Alright. And how do we calculate the formal charge? And to calculate the formal charge, just draw a circle around your central atom, and now these 2 electrons were being shared by this oxygen, right? But when we talk about individual contribution, so in this structure, oxygen has only 1, because when this oxygen met this hydrogen, both of them, came with 1 electron, and then they shared. But before sharing, this oxygen had only 1 electron. Similarly, this oxygen had only 1 electron. So how do we calculate the formal charge? Formal charge is originally present electrons in the valence shell minus the electrons in structure. So oxygen, to calculate the formal charge for oxygen, in original structure, oxygen has 6 valence electrons. So 6 minus electrons in structure. So in structure it has 1, 2, 3, 4, 5. I'm just talking about oxygen, not the shared now. So 6 minus 5 is plus 1 charge. So oxygen has plus 1. Similarly for hydrogen, the originally present is 1. In the original state, right? But in the structure, it is also 1, only 1. So 1 minus 1, 0. So 0 for this, 0 for this, so 0 this, overall is plus 1, that is plus 1. So it means this is a stable structure and formal charge is closest as possible. So this is the final structure for H3O+. Okay, now by using the same method, we're going to calculate or find the Lewis structure for carbon disulphide. The first step was we have to find the number of valence electrons. So carbon, as you guys can see, it has 4 valence electrons, so 1 multiplied by 4 because we had only 1 carbon, and sulfur has 6 valence electrons and we have 2 sulfur, so 2 into 6 is 12 electrons. So the total available electrons will be 12 plus 4, 16, right? So this was the first step. We have calculated the valence electron. The second step was find the sad boy. Carbon is sad, lonely, so we just put it as a central atom and draw a straight line or just draw a single bond with the other elements. Okay, the second thing is done as well. Now we need to find that how many electrons have been used. So this single line means 2 electrons. So 1, 2, 3, 4. 4 electrons have been used, right? So we have used 4 electrons. So the remaining electrons are 12. So we need to adjust these 12 remaining electrons as lone pairs. So 12 remaining electrons mean 6 pair. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So 12 electrons have been adjusted. Now we have to see if the octet rule is satisfied or not. So if we see it, this carbon, so this one has 1, 2, 3, 4. Oh my god, it's not happy at all because it has only 4 electrons. It needs 8 electrons. So this carbon will ask the sulfur, knock knock, sulfur, can you borrow this pair of electron to form a double bond, or can you share this one pair of electron with me so that my octet is complete? So this sulfur is very nice, and this sulfur says, okay, you can have this shared pair of electron because I want you to be happy as well, because even if I share it, my octet won't be disturbed. Okay, so this sulfur just kind of shared this electron pair with this carbon. Now this have double bond. Now let's see if this carbon is happy or not. So carbon says 1, 2, 3, 4, 5, 6. Oh my god, carbon is still not happy, right? So this carbon will say this sulfur, knock knock. So sulfur will say who? So sulfur, carbon will ask sulfur that I have already bothered your friend sulfur and he has shared his electron, but I'm not really happy yet. So this sulfur says, okay, I'm as generous as my other brother sulfur, so I can give you this pair as well because it won't affect my octet. So we can both share it. So now this sulfur will share this lone pair of electron with carbon in the form of another bond. So now if we can calculate, this carbon has 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons, and for this sulfur 1, 2, 3, 4, 5, 6, 7, 8. And this sulfur 1, 2, 3, 4, 5, 6, and everybody is happy. Now the last step was we have to calculate the formal charge. So the formal charge was the original electrons minus the electrons in structure. So again I just draw the structure to find the individual contribution. So for this carbon, the original electrons, I knew the original valence electrons were 4, and in this structure it has 1, 2, 3, 4. So 4 minus 4, 0. So carbon has 0. Similarly for sulfur, original is 6, and in this structure is 1, 2, 3, 4, 5, 6. 6 minus 6, 0. 0, 0. So this is a stable structure for carbon disulfide.